Well, hello, everybody.
We
Good morning,
are.
good afternoon, good evening to everyone, wherever you may be, somewhere in our lovely world, east, west, north, or south. Thanks for joining us live today for the one and only, of course, it's Serverless Office Hours. We are streaming on the AWS Twitch channel and also AWS Events channel on YouTube. Today's a special show because I'm Julian and I've worked with Eric in the same team for years, and we are buddies for forever. And it's actually very rare that we get to do a live stream together because it's normally one of us hosting. And so this is absolutely awesome. Probably a silly question, but you can never assume. Eric, welcome to Serverless Office Hours. If people don't know who Eric is, what are you? Who are you?
I'll tell you. So I'm Julian's colleague. What more do you need to know? I do what Julian does, only not as well as Julian, of course, and with less hair. So, but yeah, I'm a developer advocate as well. We are on the same team in different regions. Julian's across the pond, of course, and I'm here in the States. For now, I'm in Colorado. I've been traveling quite a bit, so I am back in Colorado right now. It feels great, but I head out in a couple of days. So,
excellent. Yeah. So. Today's stream as well is also about building intelligent agents. And one thing I just want to mention is, if you're thinking, agents, I don't know, I don't care, this is actually the stream for you, because this is all about discovery and finding out maybe what agents can do. And Eric is so awesome at explaining this as well. He's been all over Asia recently, talking about agents as well. So that's why I say I don't want people to think like, oh, agents, I'm not building any agents or whatever. This is also showing you the art of the possible. What coming down the future is, because agents we think is going to be a thing, and whether it happens or doesn't happen, this is where you're going to learn about serverless super agents, and hopefully they're going to be intelligent as well. So of course we are live. Your questions or comments are always appreciated. We already have Bernard, who's joined us from Germany, from southern Germany. Hello, Bernard.
Hey, Bernard.
I'll be in Germany next week as well. Not quite southern, but it'll be cool. But yeah, we love to know where everybody is. We've got a global serverless audience, a global AI audience. So doing the big mashup all together is awesome. So yeah, please tell us where you are. And we have Jeffrey, our producer, as well, who does lots of the behind the scenes stuff, but super important to make it all
Keeps
happen.
us running. Thank you, Jeff.
Thank you, Jeffrey. So yeah, Eric, over to you. What's going on in an intelligent agent world?
Yeah, so I want to throw out, while this is kind of piling on what Julian was saying a moment ago, this is about agents. We're going to talk about agents, but it's more about the how did we do it, and it's from a serverless aspect, right? And so we're looking at we're going to talk about agents. You can't really talk about agents without talking about agents and talk about AI, right? But we're going to really get into the serverless and how do we do that, and what's the approach, and what does development look like, and so we're going to kind of wander around a little bit today and see what happens. And I'm ready when you are. So we'll jump in.
Off we go. Yeah, this is obviously we're live on Serverless Office Hours. So yeah, it's the only way to do live coding, because it's all going to be live. So all mistakes Eric will entirely own, but blame the AI, which is always the perfect way to do.
Fat finger. That's right.
And thanks, Rahul Sharma. Thanks for joining us from India. Super cool to have you with us.
All right, so first of all, and now you know me, I don't like slideshows on Serverless Office Hours, but I do want to show one slide. This is the architecture that we're building. And let me give just a little background on what this is and why I built it. And I've actually been presenting this, like you said, across Asia. And so the story is this. I've got this buddy, he's an acquaintance, someone I know through our church, right? And we have this program that he runs, and it's a disaster relief program. And the way this works is if something happens, we have a fire somewhere, we have a tornado, an earthquake, a flood, a hurricane, all these bad things. He has a team that responds, but more importantly, he knows what needs to happen. He knows the logistics. He understands the explanation of who should be on site, what they should be doing. And it gets really cool because he can say, look, if you have, let's say you have a fire. All right. So let's say we have a fire somewhere, and he said, okay, well, if a fire is here and 10,000 people are affected, then he knows, look, we need 7 ash out crews. We need 9 food trucks. We need, 3 security trucks, whatever, so on. That, and of course I'm making up that data, but he has that all in his head, right? And or written down on a yellow legal pad or something like that, but nowhere like where it's available, right? And so I got to thinking one day, Why? And I don't want this to happen. So if you watch this, Dennis, this is not what I want. But what if he gets hit by a truck? Right, and so there's that kind of thing. And I know someone's asking for a link to the slide deck or the blog. There isn't at the moment, but I'll be glad to share this out. Yeah, we can share this deck out.
Thanks, Peter Wolfie.
So yeah, watch for that afterwards. So anyway, I got to thinking, could we build an agent that you could make this work with? And so I did that. And so let me actually show it to you first. So I'm going to start it locally at the moment, and I'm going to switch over my screen now. Okay. And I'm going to explain some things. I have to remove. Oh, Julian. Oh, there we go. My mouse stopped working for a minute. Oh, boy, I hope that holds in there. Okay. How interesting is this screen right here? Okay. So I'm going to run this locally for a moment, and I'm going to explain some things about how I developed it as well. If you remember the architecture, my agent actually runs in an ECS instance on Fargate. And there's a new announcement coming out today about that. I'm not going to say it yet because I don't know if they've pushed the announcement yet, but watch, we're doing some really cool things with Fargate as well. Little plug. If you want to know more about that, we're going to talk about it on Thursday on Containers from the Couch. Sorry, Julian, I just took that moment to plug through. Yeah. So anyway, so my agent runs on ECS, and the reason I did that is I wanted it to be long running. Maybe I want to run. I want to be able to manage the CPUs or something like that, or vCPUs. A lot of different reasons, but basically, this is where I'm running it. So I'm going to start that up locally, and here's a really cool approach. So I'm going to do Docker. Compose, it's already there. Build. So Docker compose up -d build. And I'll show you why I did that in a minute. But let's get it started so I can actually at least show you.
Can I just ask a silly question? When you say you are running the agent as a Docker container, this agent is actually going to be running locally. Okay, it's running in ECS Fargate, but at the moment you run it locally. So what's the sort of local remote? I haven't figured out how the client then connects to the agent and sort of what an agent is in this part.
That's right. So what I'm going to do, as soon as I get there we go, Docker logs, there we go. So what I'm going to do is I'm running it local. But now remember, I'm a serverless developer, and I run a SAM, which, I have the squirrel. You want to put the squirrel costume on? I will. But I'm a SAM guy. And when I run SAM locally and I want to run that, or I run the new local stack, if you're following, we've just done the new local stack. I can run local versions, and I can call out to the cloud, either in local stack or out on AWS, because I have the local permissions. And I want to be able to do that here on mine. So I'm going to run my ECS in a local agent, but it's actually going to call the actual Lambda functions in the cloud that are MCP servers. It's going to call the S3 bucket that I'm running as a vector database. I'm actually doing that through Bedrock. And we'll go back to the agent or to the architecture in a minute, and I'll kind of re-explain that. But I do need to be able to call out to those. So I have this special configuration, and let me actually show that really quick. Actually, no, let me finish this demo, and then we'll come back to that, right? So I got this up and running.
Just quickly, this agent is not actually deployed to ECS Fargate. It's just a container running locally at this stage.
The one I'm going to show is not deployed, but there is actually a deployed version of this. It is working. I don't mess around with that because we're using it in some different examples, and some other people are now starting to give this talk that I just did quite a bit. So I don't want to mess around with that. So I'm going to run locally because that's where I should be developed, right? But yes, it is running in ECS Fargate, but what you're seeing right now is not. It's running on a local container that all I have to do is push up, and then it would deploy to ECS Fargate.
So what is the client, the local client then? Is that just this website which then is connecting to a remote API via a load balancer to ECS Fargate?
Right. So the way I did this is, and now when I get fully finished with this, I'll probably move it to Amplify. But the way it is right now is it actually runs on the container as well. Okay. So there's a couple reasons I did that. One is cores. Need I say more? Nobody loves cores, and I didn't want to wrestle with that. I know, and I know you've used this too, Julian, but I've said in presentations before, if cores had a face, I'd punch it in the nose. Nobody loves cores, right? So I did that. The second reason is I could quickly update it and push out changes. So it's just part of the container, runs in there, and then it has access to the agent underneath. Okay. So this is a front end calling the API to talk to the agent, right? Does that make sense? Okay, cool. All right, so let me blow this up just a bit. And these are great questions. I've given this presentation so many times, and this is a different angle, so you're helping me kind of explain that. So, all right, so we've got this weather thing. Now, real quick, Julian, you know that I'm not a designer, right? So let's not judge my front end, okay? I just want to throw that out there. And for all of you that are out there, don't judge my front end skills. Claude helped me out a little bit of this. Kiro helped me out a little bit of this, but they're not good. But it works. So, all right, so here's what I'm going to do. So we'll use the example I have on there. We'll say there is a fire in the Tenderloin. Do you know what the Tenderloin is, Julian?
San Francisco.
That's right. Yeah. When you ask
there
all across Asia, nobody knows.
Oh, yeah. I have walked around there many times late at night. I've got stories for another time.
But I thought it'd be interesting to use this because it's not a city, right? It's kind of a location. And one of the MCP servers that I'm using is actually the Amazon location service, which is able to say, oh, I know where the Tenderloin is. I can figure that out. So I kind of use this as an example on showing how it's going to interact with the MCP server. And I'll show that in a minute. So let's go ahead and hit enter here. And the agent's thinking, and I've told it to be very, very verbose. I want you to tell me exactly what you're doing. And so it's actually going to load up here. So it says, okay, to respond to the fire in the Tenderloin, I need to gather information about it. So it's going to gather weather information. It's going to gather historical information from FEMA. It's going to gather census data from census.org. It's going to collect all this proprietary data that he has, including volunteers, and it's going to create a plan of attack. Okay, so here you go. So we can scroll back a little bit, and here's what it says. Okay, I found the Tenderloin. That's in San Francisco. Here's the coordinates. The weather currently, so it's kind of like, I don't think there's a fire, but if you say there's a fire, because it's 66 degrees. The population affected, it's going to look it up and say, well, you got about 3.14 square miles, so it's going to affect 2,591. It actually pulls that from census data, and it knows the tract. The population density, it's going to tell us what that is. Then it says, hey, here's what's happened before. These are other things that have been reported there. Now it's going to break down the cost for me. And this is based on kind of mock data that I've put in and gave it some information. But it says the total estimated cost is $429,000 to help out, right? And this is just to come in and help. It's not to replace buildings or anything like that, just to help. So what we need ash cleanup crews, we need communication hub, mobile food service, so on and so forth. And then it's going to go find in 50 miles, I have 10 volunteers that can bring equipment and we can get to work. So I can go, I can communicate with it. Okay, I can say, okay, look, this is going to take a while. So what is the 7-day forecast, right? Say, well, okay. To do that, I've already got this information. And so we're using all the things you would in an agent. We're using history, we're using context and things like that. So there's your 7-day forecast, right? So this is kind of what we're going to build. I showed that. We can come back and show a little more of this later, but just to give you the idea of what we're doing here, right? So I want to show you how I started. And what I did is I went in and I said to Kira, okay, there's a certain way I like to build things. Okay, I'm a SAM guy. I use SAM for everything. Even the containers, I want to use SAM. And so what I did is I built this prompt. And I'll show
Eric, 2 seconds. Can we just, in 1 or 2 sentences, what is Kiro for people who don't know what Kiro is?
Yeah. Kiro is a coding agent, right? It's Kiro.dev. You want to check it out. And it's based on Claude. And it uses, and the cool thing about it is we have what we call spec-driven, which I'm going to show in a minute. But it's not just vibe coding, which vibe coding is great. We can vibe code like crazy. But you can also do spec-driven development where you can actually tell Kiro, this is what I want to build. Now spec it out for me, and then we'll build it. And that's kind of what I did on this. And I've been working, this is a work in progress, so it's not completely done, but that's how I worked on that. Does that help?
Sounds great, yeah.
All right, okay. So let me show you my prompt. And actually, I'll just pull it in here real quick so you can see it, maybe. Yeah, there we go. Okay, so it's just a markdown prompt. Now this is going to look, Kiro has a concept of what are called steering docs. And you can tell it, hey, every time you do a prompt, add this as context, and that's a steering doc.
Can we just zoom in a bit? Because I know people will be like,
yeah, I'll be glad to. Let me blow this up here real quick here. There we go. So there are some things that I want. I tell, look, for AWS credentials via environment variables, how you want it to do it. This is the region I always want you to work in. I give it, so this here tells it not to use pagination whenever it uses the CLI, so your agent doesn't get stuck. And there's some things here. Always use profile demo 2, actually. Always use this region and use the pager. So there's different things that I have. I always wanted it to be serverless first architecture, use AWS managed services where possible, so on and so forth whenever you're building, okay? Now, you may say, Eric, that in itself is a steering dock, which it is, but I'm actually going to go in here and I'm going to tell Claude, because I've given it some links in here, okay? So I'm going to say, Kiro. So I'm going to say, create a steering dock based on this criteria. That's it, okay? And then I'm going to paste it. Now, because I'm added, one thing I didn't show, and we'll let it, while it's kind of generating, I'll show you some more of this real quick here. Down toward the bottom, I did document references. I said, hey, here's the strands agent that I want you to use, because I always use the strands agent for my agent to build out. Here's the MCP Lambda that I want you to use. This is actually a Lambda library built by Mike, one of our wonderful DAs who built this out. And then in SAM, I want you to use the SAM model, and here's some documentation on it, right? I also give it some information on how to do, I don't think I did in this one. But yeah, but I can also give it, I use step functions a lot, and you'll see more of that. And I like, I want it to, I like to tell it, how do you build step functions? Specifically, use JSON-ATA all the time and use variables when possible. And so I have, and I'll have to jump over and grab that, but I add those kinds of things as well. And so what it's doing is actually creating a development standards steering dock, and it's going to call out to these URLs and get some formats and structures on how to build the agent. So it's more than what I'm showing here. It'll actually add on to that. You can see it in here. Kiro, here's the development standard, and we'll let that run for a minute while we're kind of talking through this, and it'll take it a second to build that out. But while I do that, I want to go back to the agent real quick, I'm going to actually add the screen back in because I want to show, and this will pop up and then we'll come back to it. But so let's climb into this real quick, and let me go forward just a couple more. There we go. So here's how the agent works. So I run a local, like we talked about. This is that page that we have, or the website. It runs on Fargate. A Fargate agent runs, there's my ECS, and I can add or I can add multiple tasks, and I can have it scale as I need. And then I'm using history. I'm just using how you doing? Oh, I'm giving away some of my secrets. So I'm using a session table in DynamoDB. Then I use API Gateway. An API Gateway is restricted to just the agent. Not just anybody can call this. It's going to be a private API Gateway. It's secured back there. And then I'm using the new Amazon Bedrock Vector Index buckets. So I don't have to run an OpenSearch or a Snowflake or something like that. I don't have to run any infrastructure. I just pile it in there. And then I have 5 MCP servers. The first is a location service that I talked about. I have a weather service that just wraps an API. I have a resource that actually brings all his structured data in. I have FEMA and census for FEMA's historical data and monetary data, and census is obviously population data. So that's kind of the structure that we're working at. All right, so let's go back to this, and it's actually built out the thing here. So you can see here, it has gone out and figured out what does it take to look like to build an agent. Right, so that wasn't in my documentation, and so it's got some examples of and it says here's how I want you to build that out. So this is now my doc. It's much bigger for when I did it. Oh, looky here, I did have it. I told it to go out to these resources, and now it knows how to build states function or step function, including the proper syntax. So now Kiro's going to be armed with all this while I build. Right.
But I think that just to reiterate, this is the difference between a spec-driven development, because there's a sort of gated process where you say, build my spec, then you can go and review that step and look and find the mistakes. and then it can go and build an implementation plan and all those kind of things. Because sure, you could one-shot this in a vibe code, but when it makes a mistake to go all the way back and do stuff is a pain. So actually having this multi-step process makes it so much better and so much sort of more deterministic and correct, because each stage you can have a read through what the AI is basically saying, this is what I want to do, can you give it a check? And then you can always go, oh, I missed that, or I didn't think of that, or remove that, add that. And so I think, yeah, for me, that also works so much better.
I agree wholeheartedly with you. I want to give it some guidelines. It may do it right, but it doesn't do it Eric Johnson's way. And of course, Eric Johnson's way is right. Maybe Julian's is somewhat, but Eric Johnson's way is right. So yeah, it's important. Okay, so the next step is, and there's a great segue, is we're going to actually spec it out. Okay, so I have this prompt. I'm going to go ahead and hit enter so it can start it out. But I've switched over to spec mode. I've got autopilot on. We're going to go ahead and hit that, and then I'm going to read you the prompt. We'll just pull it in here while it's working, and we'll blow it up a little bit. So this is maybe I'll blow it up here. There we go. So now, Julian, my spelling has not gotten any better. So let's just be clear about that. But let's get, because I want to build a rescue agent. Given a disaster and location, this agent can determine the number of folks affected, the course of action to help them out, and the estimated cost. We will use tools like Amazon Location to get location. Locate there. Yep. Okay. Location details. Open FEMI, which is supposed to be FEMA, for historical data of an area. Census.gov, also spelled wrong, for population data. Open Medio for weather, and DynamoDB for proprietary structured data on resource and cost. I will also use the new vector buckets for non-structured data in the form of knowledge base. So you see, so one, my spelling's bad, but I've told it what I want to do. And the tools that I want to use. So what it did is it said, okay, we'll go ahead and build out here's your spec. And so it's written these, here's the design, and here's the requirements. Okay, user story number 1, as an emergency response coordinator, I want to input a disaster type and location so that I can quickly assess the scope and impact of the emergency situation. And it's a full set of stories, right? Now, the process here is I'll go through these and say, okay, I like that, I don't like that, change this, change that. But I may not type in. Some I'll do that, but I'll go, no, I don't think you're understanding me. So I may give it instructions to update. So it's like a conversation going on. But we're going to move on for a moment because I want to see the design doc. And that takes a few moments to draw out. But what it's going to do is it's actually going to create the design that we're going to build on top of. So, and while it does that, and notice it's calling out, finding it's using my context, and it's calling out to MCP tools to get some documentation, kind of figure out things. So Kira's doing a lot of work that I really don't want to have to do. Anytime you see a failed like that, don't worry about that. It may have just had a problem calling or something like that. It's going to keep trying. So now it's going to create that. Now, really quick, while it's doing that, Julian, do we have any questions that have come up?
Nothing specifically, except for the obvious comment that Eric is very funny man. Nice. We have Will from Brazil. Will from Brazil, thanks for joining us as well. Immortal for something said, any links to the docs? Eric has said he will post something up after as well. I think this is down the road from you, if that's Arizona or AR or Armenia. Ooh, maybe I've got the wrong.
I don't know.
Dragovinsky could be Armenia.
It's not Arizona.
I was just thinking AR straight away.
Yes. No, it's all right. Okay, so our design doc is done. So this is kind of cool. So if we go into our design doc, one of the things it'll do is it'll actually do and I'm going to tell it to go on to that it's going to go on to the tasks. I probably should have done that because I'm actually going to change a few things. But what I like to do is if I go into the design doc, I can actually pull up a preview. And let's scope this over a little bit so we can see everything. Yeah, that'll work for now. And there's our architecture. Okay, so here's my front end. Here's my strands agent, back end layer. There's the vector knowledge base, just like I want it, where it's going to talk to the S3, DynamoDB. My agent's it used to do an MCP, but it figured out my agent's going to directly interact with the DynamoDB MCP server. Oh, no, it is an MCP server, so we'll probably actually change that out. Open Mateo, Census, Open FEMA, Amazon Location. There you go. Now, we could change this up. So for now, I'm not going to do it just because I want to know time-wise, I want to make sure we cover a lot of stuff. But I could go in here and say, hey, let's make sure that I'm running. Well, let's just do it. So for the design doc, we'll do it and then we'll move on. So doc, I want an ALB in front of the ECS container and all the MC. I do this when nobody's watching too. I talk while I type. So, and all the MCP servers behind a private API gateway. You kind of chuckle at me. I actually have my dictation turned on my Mac where I can actually talk to it. It's not always great, but it works. So what it'll actually do is it'll actually go out and go, okay, yeah, I can change that. I'll update this, and then it'll tell me how smart I was for security reasons, to do this move. I always like the little complimentary things that Kiro and Claude do for me. So and there you go. So now we've got the application load balancer for the agent, and then in a minute you'll see the API gateway pop in, and it'll be a secure API gateway. So that's how you do kind of the design, and then it's gone through and it's done the tasks as well, and I can tell it to update the tasks based on that. Okay, I just threw a lot at you. Julian, any questions?
Yeah, it's doing a lot. I would think that there's a bunch of work here as an architect, as developer, to go through and see what makes sense and see what it's got wrong, or see what I didn't understand.
Yep.
But yeah, I mean, this is doing a vast amount of work, which would be super appreciative, rather than just yellowing it and starting to build. So I can certainly see the benefit of that.
Yeah, massive amount of work done for you up front. So, here we go. We do have a question. Nicole Dang says, any reason to host agent on Fargate but not Lambda? Well, that is a fantastic question. Both would work. Okay, here's the reason I went with Fargate. There's a couple things to think about. One of the things we think about, and sometimes people think about this first, is, well, Lambda can only do 15 minutes. However, if your agent is running longer than 15 minutes per interaction, might be problematic, right? Because what it really looks like is I'm going to ask the agent a question, and then it's going to grind. The agent is just an interface to the model, right? It's going to talk to, okay, model, you do reasoning for me. Oh, I got to call this tool. I got to call this tool, blah, 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 blah. And then I'm going to feed information back, right? And hopefully that happens in under 15 minutes. Then the next question you ask will invoke that Lambda again. So you have a new 15 minutes, and your interaction will be, you'll have your session and your context, so it'll all be there. So that does work. The reason I chose Fargate was because, one, I've been playing with Fargate and I love it, and I love the interaction of building a hybrid, but that's more just preference, right? But two, I wanted streaming. Now you're like, hang on, Eric, you can do streaming through function URLs, and you're absolutely right. But function URLs, I'm going to say this, and someone might tackle it for me. Julian, we're not recording this, right? So, but function URLs, the only security you have is either IAM, which is no fun to write IAM for client-side calls, right? Because you got to sign it, and that's how you can try. You can download the SDK and things like that, but that's kind of problematic. Number two is the other way is you write your own JWT security, and I didn't really want to do that. Instead, I can use an ALB. I can use the OAuth security that's built into ALB, where it'll go out to Cognito and sign it up, and then do that, and then I can stream true streaming through the ALB. I also wanted to maybe pop on some other things. Maybe I would have some sidecars. So that was the reason that I chose that. Hopefully that helps a lot.
Cool. We do have another question just here while we're talking on the architecture. Where is the MCP client that connects to the MCP server?
Okay. So the MCP client is actually the agent itself, right? And so it's built into the agent. So here's how an agent works. When the agent comes up, so when we initialize this, and this is going to be another reason I chose ECS, and I'll explain it in a second. But when the agent comes up, it makes a call to each MCP server and says, hey, are you there? And the MCP server says, yeah, I'm here. So that's the initialization. Then it makes a call and says, hey, what do you do? And the MCP responds says, I do this. I do this and this and this. And in order to get that, you need to give me this and this and this. So for instance, I give you weather forecast. If you want, you need to tell me the location and how many days you want. And then what happens is the agent basically makes that part of itself for that session. It says, okay, I've got these tools. So you can have tools built directly into the agent or MCP servers, and it'll kind of combine them all in its understanding of what's available to it, and then it'll use them. So that's the client. But one thing I noticed is I was having to load those up every time. So every time I asked a question, it would reinitialize and make all those calls. So I asked Kiro a while back, said, hey, Kiro, can you cache the initialization? And Kiro said, yeah, Eric, I can. I'd be glad to do that for you. So let's go ahead and cache those. So now when it makes the call, if it's already cached, it'll check, go, oh, hey, I already have the tools. Here they are. So that saves a lot of conversation going on. So that's another reason. And no, I probably could have done some Lambda function magic. Sorry, Chris Munns. Lambda function magic to cache that maybe in an attached, what do we call that? Where we attach a hard drive or maybe stored somewhere.
EFS for Lambda or an external database or something. Yeah, could have been Dynamo.
I went blank on that. Yeah. But I can do it locally on the container really easy. So that's it. So to answer your question, the agent itself, which I'm using the Strands SDK, that's the client for the MCP, and that's why I chose the server. All right. Oh, good. Jeff said this is just between us. We're not recording anything. That's great.
Okay.
Thanks, Jeff.
Excellent. So we can say anything then.
Yeah, exactly. Let's go to
in fact, Jeff is so good that when Dragovinsky came, Jeff sent me a message saying this here from Argentina. So could very well be Argentina. So
there you go. Thank you, Jeff. Jeff is probably 2 to 3 times smarter than us combined. So there it is. So okay, so let's get out of this. We've kind of gone through how that works and stuff. And so now I'm going to show you, let's get the actual repo that I've got this on. So obviously I've built this already. So we'll open recent and hopefully it'll stay. There you go, rescue. I've had a lot of questions about the repo and things like that. Some of this repo I can't put out yet, but I'll put one out that's kind of been generalized, and I'll put that out. And so glad to help with that. So we have another question that came in real quick here. Is this functionality specific to Strand framework or can be said? Yeah, so yes, you could do this with Bedrock agents. You could do a lot of this right at Bedrock. I wanted to back it off and build it in serverless because I like to turn the knobs and levers. I wanted to have some control of that. 2, another good reason is, what if I need to call something else? What if I want to call Claude directly? Let's say I need to fall back or something like that. One of the questions I get asked on the road a lot is what happens, and to be honest, I've never seen them. So what happens if I run out of capacity or I something happens as we have an incident with Bedrock? What do I do? Well, the agent can call directly to Claude. It can call directly to Chat, OpenAI, or it can, some other things like that. But I need it off of Bedrock to do that. So I'm doing that built into the agent. But you could use something like an agent core to build this out if you wanted. But I like to have the control there. So hopefully that helps. All right, so let's see this in action. I want to show you the development. And earlier I said, one of the things I like is to let my local container be able to talk to the services in the AWS cloud, okay? So this is the magic behind that. So here's my Docker Compose. Let me get rid of this real quick. And I don't expect, we're not going to explain all this, but you kind of get this idea. This just says, hey, where's the agent? Where's the Docker file? What port should I expose? And then let's attach some volumes for editing and things like that. And then here's some environment variables. And these are the actual hard-coded links. I'll probably parameterize them at some point. These are the links to the MCP servers, right? So what I'm going to do, and then this is a sidecar. Okay, so what this is going to do is this is going to come on and attach itself, and it's going to emulate the credential server that's inside of AWS. So when I have an ECS container on AWS, it will call a specific endpoint, and it'll get the credentials it needs. So this will do it based on the roles and policies that I give it and that I have access to. I have to have access to those. And it'll act just like it's in the cloud, and it'll have access to call those. Is this not cool?
So basically, that is cool, and it's mounting a Docker volume to your local.aws and your home file, which has your credentials. So it's just connecting to your local file system, looking at your profile, and then it's got some stuff in there that,
and then emulating that, building that out. So I've got a link. I'm going to post this real quick in the I'm on YouTube and Twitch. So here's a link to the blog post that does this. So just so you have that, it was super helpful for me. So anyway, so that's why I'm using Docker. So what I tend to do, so remember, some of this is on Docker and some of this is on serverless. So, well, Fargate we're calling serverless, but some of this is on Lambda functions. So I want to be able to edit both. So let's go ahead and look at, I'm going to do a couple things here. So I'm going to start a SAM sync. And if you're not familiar with SAM sync, what SAM sync does is it actually watches your files, and as you make changes, it calls the API and it makes quick changes in the cloud. So this is actually changing my Lambda functions in the cloud. Now, the first one I do is actually going to be an infrastructure deploy. So when you start SAM sync, it's going to actually check and say, okay, I need to push some new stuff out. So SAM sync's been around for a while. I use it all the time. Now, you may ask, Eric, why don't you use a local stack for this? I absolutely plan to. Actually, the local stack feature came out kind of after I had this already set up. So I'm probably going to move over to that at some point, but I'm not at the moment. So, okay, so I figured out. It said, hey, you don't have any changes. You're good to go. So we're skipping an infra sync. All right, so now the last thing I'm going to do is I'm going to start my logs with a tail. Okay, so I'm ready to develop. So I like having this window. So right here is the Docker Composer. Right here is my Docker, and I should tail that. Oop, tail. Yeah, that works. Thank you. Okay. Oh, did I kill it?
No, you got an N instead of T.
Yeah. Well, N is supposed to work, but let's see what happens. Okay. There. Oh, no, I'm doing something wrong here. Hang on a sec. What flag? Okay, flag. Okay. I'm doing tail. Why is this giving me? Oh, maybe the tail 100. There we go. Okay. So, all right. Yeah. So this session termination failed. That's okay. What I'm doing is in my MCP servers, I don't deal with sessions in MCP servers. So let's talk about that for a minute. Okay. In MCP servers, you can do sessions if you want. And the library I'm using actually has that as well. But I don't think an MCP server needs a session. An MCP server should come up, do the work, and go away, right? It's a tool, right? It shouldn't need a session. The agent should have the session. The agent should be aware of everything going on. So if it needs that tool again, it'll send it the information it needs. So that's why we see this session termination. And I need to, Kiro and I went back and forth a couple times. Like, I want to get rid of this error. And we can write some code to catch it and stuff like that. But Kiro was like, it's not hurting anything. I was like, okay, just leave it. So there you go. All right. So let's go ahead and run the agent again now that we've done this. And we'll restart that just so we have it. And I'm going to say there is an earthquake in Denver. Okay. It doesn't happen very often, but we'll say that. So what I'm
just to say, this is dummy data. There isn't actually an earthquake in Denver. In case
there's not. I'm sitting near
Eric's
Denver.
Not listening, going.
That's right. That's right. Okay, so hopefully you're seeing there's stuff going on right here. So these are our Lambda functions being talked to, and they're giving the information.
So you're looking at the live logs of everything in your stack.
That's right. Right. This is the live logs going on there. This log I apparently still don't have on correctly, so we'll come back to that in a minute here. So I know I've done this before. Okay, so now you're learning how bad Eric is at Docker, but I'm learning this. So we'll leave that alone for a moment. But all that's going to show us what's going on in the agent, which is actually right here. Okay, so we've got some information on what's going on in this area. Denver. Now, I don't think that's correct. This is, like I said, this is a work in progress. So you can give it. So I can actually ask it. I can say, what radius did you use for the earthquake? Okay, I need to determine a radius. So the radius you used, okay, was 10 miles. So it's only pulling one census tract. And I've gone back and forth with the agent on this. And this is something, let's talk philosophy of building agents and tools for a moment, okay? So when you build an agent, and this is Eric Johnson's opinion, okay? And Julian, I'd be interested to see what you think on this. But when I build an agent, the agent should be unaware of the tool until it imports it, right? Of an MCP tool. So I shouldn't be hard coding anything into the agent that to use that tool, right? Because I mean, that's just good code, right? We should
Tools
never
may
have
change.
part of our code here, right? So in order for the tool to work properly with the agent, and mine is not, so I need to do some work. I'm going to have to go back to the prompt. It's all about the prompt. It's all about what do the tools provide and how does the prompt use that. And so one thing that I kept, and it was kind of interesting way back, and Kiro's actually much better at it now. But Kiro, so let's do the weather for a minute. The weather's a good example. When I was doing the weather, the census. When I was doing the census, it wanted what's called a FIPS code for the area. The FIPS code is just like what state it is and stuff like that. And so Amazon location services can give that FIPS code. But what it kept trying to do is like, hey, let's hard code a dictionary of FIPS codes right into the agent. And I was like, no, you can't do that, right? You can't do that. Instead, you need a better definition from the location service of what it does, and a better definition from the census service on what it needs, right? And so what I did is I got it to understand, if you need a FIPS code, go to the location service, ask that, and come back. And then the weather or the census, what I need to do is I have to go back into the prompt. Is what I really, right now, what it's doing is it's taking one census. And when I expand the radius, it's saying, well, if you have 2,000 people in this and you expand the radius to this, well, then we'll just spread those 2,000 people out. What I really needed to do is say, when I expand that radius, find out all the other tracks that are in that radius.
Yeah.
And then find the population of each of those tracks. So I have to go in and fix that. So that'll be work for the weekend, right? And so I'll be working on that on how we build that out. So hopefully that makes sense, though. If you're building an agent and you're working with tools, it's all about the prompt. These are non-determinate, right? Or these are what's the word, Julian? Non-determinate? Yeah, non-determinate.
Yeah, non-deterministic.
Non-deterministic. Thank you. And so it's a lot about just explaining how to reason against that, right? So
and also because your tools may be existing APIs that connect to data or those kind of things, and you may not be able to change them either. So you've also got to get clever with what the LLM can provide and send back to, maybe ask multiple tools within the same service to get different information.
Yeah, that's exactly right. And teaching it where to find those can be tough. Okay, so we've got an error in our logs, right? And so this is kind of cool. So it says, hey, an error occurred while executing the state method router. Now, before I explain this error, I kind of want to show you something. And I gave it away earlier in my slide. I'm going to bring my slides back up real quick here. Okay. I asked the question, what if we wanted to do this in AWS step functions? This being MCP servers. Now, if you know anything about me, I love step functions. I speak on it at reInvent every year. I absolutely love it. I love playing around with them. And so I said, okay, let's try this. Now, there's some pros and cautions on that. It is low code, no cold start. Step functions, express step functions run in memory. So that's going to be immediate, right? It's funny because when you're watching the logs, like, oh, the logs take a little bit. Oh, no, it executed. It's executed, done, and gone back to sleep. It went and got some coffee, right? And so, and then you have to know a little VTL to integrate. And VTL is velocity templating language that runs in API Gateway. And that's a whole nother 10 sessions we can do. And there's no MCP SDK support. So you kind of have to manually build out to the spec. That being said, this is what it looks like. And actually, we can actually bring up the step function for that. So let me show you. Let me go back to my code here. And so what we did is I went in and I built 2 step functions. Let me find my code. There we go. All right. So you have the router. So let me go into my MCP server. So this is the router. Now, if you haven't ever seen this, you can actually open and use Workflow Studio right inside of Visual Studio Code. Kiro is a fork of Visual Studio Code, and you can see here this is the router. And so his job is to say, okay, I'm going to set some variables, and then I'm going to look at the method. What method is it? If it's an invoke, meaning, hey, are you there? Then respond. It has a actual step function. Oh, I'm sorry. The invoke will actually call a sub-step function. We'll come back to that in a second. If it's initialized, which is the hey, I'm there, then it'll initialize. It'll respond, yes, I'm here. And if it's an actual give me your tools, the tools list, then it'll actually query the sub-step function and return the tools list as well. And so to respond to that. Now, I have 2 tools. So these are subs. So this is the get weather forecast. And it comes in and it has a method router as well. It says, okay, if you just want a list of my tools, then here's my tools. If you want to actually invoke, then I'll call the API for you and respond with the data. There you go. So there you go. So now I can add multiple tools to this very easy. All I have to do in the main one is under variables, I actually register. Let's pull this over here. But my screen's so big, so bear with me. I register the arms of the machines or of the other ones. That's all I have to do. Here's the name and the yarn, and that's it. It does the rest. Okay.
So schizophrenic web developers come, a route is more than like one or more case statements, like using if else or a switch statement, which I'd like to say yes, but it's also, if you think of it like an API route, that's the same kind of concept. If you're coming into an API, which path do you go down? So yeah, router is like a switcher, exactly.
Yeah, good. Now, I have a problem with mine, and my logging has told me so. It said, hey, an error occurred while executing the state method router, which is that first one. It entered it at event ID number 4, and it failed to transition out. And the reason is the state does not point to a next state. So what it means is I actually know what's wrong here, but it's saying, look, I don't know where to go. And let's ask Kiro on that. So what I'm going to do.
So is that getting where's that getting the logs from? Is that the logs from step functions?
It's from step functions and Lambda. I'm logging everything aggregate.
Yeah,
it's just rolling
but
it out.
That particular log is coming from step functions, and
that's exactly
and that's
right.
the power of SAM logs, is having, part of the cleverness of structuring your microservices is if you have them too small, you've got to jump along too many different kind of things. Here you go, you're just doing one SAM logs and looking for any errors across multiple services. Awesome.
There you go. So, and you can see where it's coming from, states, weather MCP, step function, I can go right to it. Okay. So what I'm going to do is let's go back to Kiro. And I'm going to bring out the session here. And it's actually in this one. And I'm going to tell it, I'm just going to be real vague. I am getting an error in a step function. I'm going to give it the error. Yep. I copied the wrong thing. Hang on a second. Go back to that real quick. Now I can actually filter these as well. It's kind of cool. You can tell it, hey, as you're telling that, filter it. So let me grab this. Okay. So I'm gonna have Kiro kind of, okay, let me figure out what you got there. You can see it's giving my steering docs in here. These are the things I like. It says I can help you. Method router doesn't have a next field. Okay, so it's just repeating back to me right now. So, okay, so it's looking at the different ones. So it found the issue. Okay, yeah, here it is. So the method router, the choice state is missing a default field. You always have to have a default in case everything else fails. Okay, so now it updated it, it fixed it. Now watch this, and it's going to tell me what it did. No compliments for me because I didn't fix it, but he did. So I'm going to flip back to my thing and look down here. It said, oh, we found a problem. Oh, and it actually this kicked it out when I tried to build it too. We found that you made a change in a file. Let's go ahead and sync it up, and it's already done before I could get back here. And now my fix is out of my development, and I can test it. So I can go back. So let's do the same thing again here. Okay, so we'll just say we'll start a new one here. We'll go. There is a flood in Fort Lauderdale. There we go. Okay.
And
so we'll go ahead and hit
developer is on the money and understanding things like a switch statement. We also have to have a default case, like a catch-all thing. Exactly.
That's right. That is exactly right. So I'm gonna pop over here, and you're gonna notice this time it ran. It assigned the variables, and everything went through fine. And there are no errors coming up here. I'm trying to do it slow, but it's obviously moving much faster. Now, note that the speed that these logs are coming in is not the speed that the state machine. The state machine's done, right? It's just pulling and grabbing and getting and aggregating in those logs. So they'll come in a little bit later, but now you can see the answers that it sent back, and we have no errors going on, and I got a response, and here's what's going to cost me to do the flood. And there you go. Now you can see it's got 50 available, so I can say list the volunteers. Volunteers like this, if I spell that right. And it'll actually go through and list them. And there you go. List all 50. There we go. All righty. What questions do we have? Because we're almost at time here. I could probably show some other things, but I want to see if we have anything else going on.
Well, more about the switch statements or all of that kind of thing. Of course, Bevanth, Fadili, thanks for joining us via YouTube. Yeah, also switch statements must have a default value. So yeah, and this is normal best practices for coding kind of things. You need to have defaults. You need to have, what's going to happen if you're writing that in code or you're writing it in step functions. It's going to be the same kind of thing.
That's right. That's right. And I'll zoom in on this so you can see it. Again, I've got it blown up, so it's hard to get everything in. But what it's doing, this is what it added. So here's my default. And now, if I were to, I actually had this code generated, and I probably screwed it up a little bit. But if I were to build this in the workflow studio, it would have thrown an error. It would have said, hey, you got a problem. I had just popped the code in the file. So
Rupia says, just to reiterate and zoom back, why use step functions here in this flow? Can't you just use API gateway and call the lambdas?
Yeah. So I'm going to get super technical on you here. So buckle up. So basically it comes down to because it's fun. I don't have to use step functions, and actually, I may not. It depends. There's a couple of reasons I use step. So let's talk about why step functions in the first place, okay? Because you get error handling out of the box. You get the drag and drop. You get direct integration with tons of services. So if I had to call a bunch of services rather than me coding. The second reason is Eric Johnson's code is a liability. Code is a liability anyway, but we have to do it. That's part of it. My mantra is if all else fails, then code, right? Code's a liability. Eric's is an extreme liability. So I tend to lean into step functions. But the reality is you don't have to. This was a can I? And I can. The downside of that is if the spec changes, which if you follow the MCP spec at all, it changed a bunch of times right up front. Slowed down a little bit, but it's still changing. If the spec changes, I have to know the change in the spec, and I have to go in and build that into my, usually it's just the response that I format. Whereas if the spec changes and I'm using the SDK, then I just update my SDK and that handles it for me. So most likely, most people will just use the Lambda function behind an API gateway, and that is a great solution. It works super well. I just thought, hey, it'd be cool to see if we can figure it out. The only MCP server I'm running in step functions is the actual weather one. I didn't do any of the other ones. Hopefully that's probably more than you want to know, but there's the answer. So,
but the big idea is two parts. One is definitely writing less code. Error handling built in, no code. We talk about, sure, Lambda upgrades and does all the stuff behind the scenes, but step functions, there's no upgrading. These things can run for a year. I mean, we've got step functions running on a bunch of stuff we've built. I mean, they've been going for years and years and years and just never even think about having to upgrade any code. So that is super powerful. And then the other part is actually with the no code kind of thing. It's so visual that it's so much, it's more helpful to understand the visual workflow that's going on specifically for non-coders, or you've got a business development person or something. You can print this out and show them and go, is this the correct flow of what we need to do, rather than understanding the code? So that is also a sort of sometimes an underrated part of it, where with the visual aspect, you can view it. And also with the error logs, sure, Eric was streaming the logs out, but when something goes wrong, you've got a red line in a state machine step on in the console or wherever. It's so easy to just have a look at that.
Yeah, so I'll pull that up. So you can go up to here. So this is the one that failed that I showed, right? And so let me refresh this now. Here's all the ones that ran afterwards. So you can actually go in. So if I wanted to, I can go into the failed one and I can see exactly what it is. So you have an audit trail, and that's super helpful. And it'll tell me exactly where it happened, and here's the error. So I can go here if I don't want to do the logs, I can pull that in. So
it's sort of like a stack trace that's easier to use.
Yeah, and I get the input and the output right here. So I mean, there's a lot of any variables that are set, so I can read all of that directly in there as well. So super helpful.
It's just, I mean, there's obviously covered a lot here. I love the demo. It's so easy to understand because it's a use case that sort of resonates and makes sense. But when people are exploring with building agents, you know, where do people get started, or what do they, you know, they may come up with a reason. There's a lot of tech here involved. What's a sort of simpler on ramp that someone can, you know, start exploring what agents can do, or how agents can interact with existing systems?
Yeah, so there's a lot of work being done. There's a blog, and I'll find it, or Julian, if you can, while I'm talking, grab Anton's on the MCP server that he did.
Yeah.
But we've done a lot. We've been pushing a lot of stuff. You know, check out the AWS blogs, and then we're trying to. I'm trying to get some stuff out on serverless land on building MCP servers and building agents. Check out Agent Core. That's another. I'll just put you just search this in Google and you'll come up right with it. But Agent Core is a great tool. Agent Core is super helpful because it's kind of, you build it all and deploy it, and it'll walk you through the instructions, and so that helps you build agents. One of the things you need to do is you need to decide on your agent. What is your agent going to be? Is it going to be Crew AI? Because there's a bunch of SDKs or libraries out there that you can use. You can use Lang, the Lang, is it LangChain or LangGraph or whichever. You can use the Crew AI. I like Strands. I think Strands is great. It works really well with the AWS ecosystem, and so start digging into those kinds of things. But this is it's a wild new world frontier. So I'm not sure if I could point you directly to a link. Sadly, maybe Julian, you have something. So,
not offhand. I've just put a link on the AWS Serverless MCP server that's slightly different. So it's not quite that server, but if you then do the navigation out of that, there are MCP servers for a whole bunch of kind of things from AWS and from other kind of things, which is useful to just explore. Because yeah, this is a brave new world, but it is actually super exciting, where you can use natural language in English or other kind of languages to then interact with your other tools. I mean, how, you know, to be able to aggregate all the data from FEMA and census and all these kind of things, and then just, you know, build an application in a much sort of slightly different way. And I think initially a more complex way of integrating, but actually a simpler way from a sort of user experience perspective. So yeah, it's exciting times. This agent opens up a whole bunch of integrations that would be super hard to do without that.
Yep. Yeah, I agree.
Cool. Excellent.
I encourage you to dig in. Yeah, just dig in. So we're at
Thanks,
time,
Eric.
So yeah,
time is out. Thanks, Eric. This is awesome. There'll be a lot more to come. We'll be covering a lot more agent stuff in the future. Next time, same place, same time next week. I'm not here. We'll have another lovely host, but we'll actually be talking about API Gateway routing rules. So we were talking about routing within here, but the actual routing rules within API Gateway is going to be cool. So thanks, everybody, for joining. Eric, as always, a pleasure, and even better to do a live stream with you as well. And thanks, everybody. Until next time, goodbye.